Hi everyone, I'm Burak from Turkey, from Bilkent University, and in this series, we will be coding logistic regression, neural networks, and convolutional neural networks with only Numpy to understand the theory and the practice of these algorithms. And this is actually the project of mine in Bilkent University course, and it's very good for me to introduce you a documentation about these algorithms and about the mathematical background of uh, these concepts. So in my GitHub you can find the full documentation. Maybe I cannot call it documentation, but mathematical guide, and also you can have all of these codes. And it seems very ugly, I know that, but I will show the important Py files in here, and we will be doing coding these algorithms with pure NumPy to understand the theory and application of the mathematics inside of these algorithms. And in my channel there are a lot of Turkish videos, but a lot of them actually also Turkish, because here is my course in MNIST, practical convolutional neural networks, that I'm talking about the practical applications of convolutional neural networks on Keras, and in this series I'm talking a lot about loading images, applying uh, solutions for imbalanced dataset problem, one-hot encoding, and it's actually very comprehensive course, and I think you should check the curriculum of it. And now in this video we will be starting coding how to prepare the dataset for our environment, and this will be the only time that we will be using other library than NumPy. And I would like to uh, introduce you my GitHub, and in this, as you can see in these files, these ugly looking directories, you can see that there's in here MNIST Py. So first you just need to load this and then run it on here. At the end of the day, if after all the things are done, I hope you will have no problem at here. There will be mnist.pkl pickle file should be appeared in there, and after that we will be taking these images, and what I mean by images are these MNIST dataset, and then after having MNIST here, and we will be coding the theory behind it. But let's first run the what we will have after some weeks, and you can see that we have training accuracy, testing accuracy, and training testing loss. And as you can see in here, we have 92% of accuracy, training accuracy, and 91% of testing accuracy on the logistic regression. This is what we will have at the end of logistic regression part. But now first load the logistic regression part of it. First load the MNIST dataset to our system, and then we will have some investigations on the dataset, and then we will be coding logistic regression with only NumPy. Well, let's import MNIST, and this is actually the Py file that is appeared on here that you downloaded from GitHub. And I need to say that this code is actually belongs to other person, but I'm not sure which person is that, so it's not written by me. I need to indicate that. But this was for course project, and I just loaded, so in my GitHub there's no credits, and I'm sorry for that. I need to check and edit to the explanation and descriptions. And after that, let's import NumPy as np, and we need to also import matplotlib.pyplot to visualize our training and testing accuracy, and also we will also visualize the weights, and I think you will find it very interesting. At the end of the day, we can compare L1 and we will compare L1 and L2 loss, as you can see here on logistic regression, and we will have some uh, explanations, and we will try to understand what's going on behind these weights, because these weights are not something magical, and because these are adjusted by us and these data is labeled by humans, so these weights will shift towards our decisions. So now, before coming to that place, there are now a lot of time to go there, but I would like to introduce you this part because I really like this part. And now just get the data, and I forgot to add it, but I need to also import random, and to have the same results with you, I'm setting random seed as 42 as a classic, and I don't know why it's always 42, but it's some kind of trend. And after that, I'm just naming the X train, Y train, X test, Y test, yes. I'm just naming the data that I have. And this is also thankfully provided by other person, and in this function we have, sorry, in this py file we have load part of it, and it returns training images and labels according to that format, so that's why I'm getting the data as this. And let's see what we have in this Numpy array, and let's run it. When we run it, we have some zeros. This is actually kind of, it makes sense because Numpy shows the extreme matrices at here. This is the first row and first column, or in Python format, this is the zeroth column and zeroth row, and you have the last columns and last rows here, and these are all zero. It is because in MNIST the only parts that represents images are labeled as 1, and the others are 0. Black is 0, white is 1. This is the idea. So that's why we are seeing this. And let's see the shape of it. So let's see the shape of it, and as you can see, we have 60,000 image and 784 rows for each image. So this is actually because in MNIST you have 28 by 28 images, and it is equal to 784. So in this video I would like to stop here and investigate the images more after this video, and after that we will be directly coding a logistic regression on pure Numpy. We will not be using any library other than Numpy. Thanks for watching.